So now we're going to look at how much excess reagent we have. How much excess is left over after the 2 reactants or 3 reactants combined. Now we're going to use the limiting reagent to find out how much excess reagent you used. So this is just an extra step. So we do everything as usual, find the limiting reagent, then we use that limiting reagent with the excess reagent and find out how much. So it's just another stoichiometry problem. And then we're going to subtract that amount of excess from what we started with. So it's just one more stoichiometry problem, and now we've done those, so it shouldn't be that big of a deal. Let's try an example here. If we have magnesium plus hydrochloric acid and magnesium chloride goes to H2, so same reaction, but we have different amounts given. How many grams of gas will be produced? Well, grams of gas, this is the only gas there, how much H2 will be produced. First we have to figure out what the limiting reagent is, and then we can figure out how much excess. So we also want to know how much is in excess. So that was not written down there. We're just going to do our standard problems. We're going to go from, we're going to do magnesium, grams of magnesium, to grams of hydrogen. And we start with 0.87 grams of magnesium over 1. We'll have 24.31 grams of magnesium in 1 mole of magnesium. Then we go to the mole ratio. Step 2, we have 1 mole of magnesium. We want to know hydrogen, so that's 1 mole of hydrogen. Then we want to know the grams. So in 1 mole of hydrogen, we have 2.02 grams of hydrogen. That's 0.405 grams of hydrogen produced. All right, now let's see how much will be produced from 9.84 grams of hydrochloric acid. We have 9.84 grams of hydrochloric acid. 1 mole of hydrochloric acid, that is 36.46 grams of HCl. In the equation, we have 2 mole of HCl per 1 mole of H2. We have 2.02 grams of hydrogen per 1 mole of hydrogen. Okay, that equals 0.273 grams of hydrogen, so that's even less. This is the least amount. The hydrochloric acid, that is the limiting reagent. Now from here we can find out the excess. What is the excess? The excess will be in magnesium, but how much is in excess? We have to go back to the hydrochloric acid. The hydrochloric acid is the limiting reagent. So now we're going to find out from the 9.84 grams of hydrochloric acid, how many grams of magnesium would be used. There's nothing special about this. This is the same thing we've been doing. So we're just going to go from grams of hydrochloric acid to moles of hydrochloric acid to moles of magnesium to grams of magnesium. That's how much is used. This is going to be the magnesium used, and then from there we'll just subtract it. So we start off right like we always do. 9.84 grams of HCl to moles of HCl. We have to go back to the equation to look at that. In 1 mole of HCl, we have 36.46 grams of HCl. We get that from the periodic table. It's a molar mass. From the equation, we know that there are 2 moles of HCl per 1 mole of magnesium. Now we have to go to part 3, going from the moles of magnesium to grams of magnesium. How many grams of magnesium will be produced with just 9.84 grams of hydrochloric acid? So in 1 mole of magnesium, we have 24.31 grams of magnesium. That equals 3.28 grams of magnesium. 9.84 grams of hydrochloric acid will react with only 3.28 grams of magnesium. Now, what did we start with? We've got to go back to see what we started with. We started with 4.87 grams of magnesium. We take the 4.87 grams of magnesium, and then we just subtract 3.28 grams of magnesium. 1.59 grams of magnesium in excess. So that's how much magnesium we have left over. If we have 10.3 grams of aluminum react with 51.7 grams of copper sulfate, how much copper will be produced? How much excess reagent will remain? Here's our balanced formula. It's all the same thing, just stoichiometry problems. We just have a few stoichiometry problems in this one problem. How much copper will be made from this aluminum? And then how much copper will be made from the copper sulfate. Then from there we can figure out the excess reagent. So I have 10.3 grams of aluminum. Now we're going to go to moles of aluminum. 1 mole of aluminum. If we look on the periodic table, that has 26.98 grams of aluminum. And then we go to the mole ratio. With the equation, we have 2 moles of aluminum per, we want to know copper, 2 mole of copper. And then we have in 1 mole, we're going to look at the periodic table. 1 mole of copper is 63.55 grams of copper, and we'll multiply that out. Equals 24.3 grams of copper produced from that 10.3 grams of aluminum. Now let's see how much copper would be produced from the 51.7 grams of copper sulfate. So we start with that, 51.7 grams of copper sulfate. And we have to figure out the moles. In 1 mole of copper sulfate, that's 159.61 grams. Step 2 here, this is the mole-to-mole ratio. We have 2 mole from the equation, copper sulfate per 2 mole of copper. Part 3, we multiply it by the molar mass. That equals 20.6 with sig figs grams of copper. So we see that this is the smallest amount produced. Copper sulfate is a limiting reagent, but we want to see how much of the excess reagent. This is a limiting reagent, this is the excess reagent. How much of that will be left after it's all used up reacting with the copper sulfate? We want to find the excess, so that means we have to start with the limiting reagent. How much aluminum will be made from that limiting reagent of copper sulfate? So we start with 51.7 grams of copper sulfate. How much aluminum will be made from that? And that's just gram to gram. Going to moles, we have 159.61 grams of copper sulfate. 1 mole of copper sulfate. We go to the moles of aluminum. From the reaction, there's 2 mole from the equation. There was 2 moles of copper sulfate per 2 mole of aluminum. Now we go to the mass of aluminum. In 1 mole of aluminum, we have 26.98 grams of aluminum, equals 8.74 grams of aluminum would be used. Now we started with 10.3 grams of aluminum. That's what we started with. So what is in excess? We just subtract that, and we get 1.59 grams of aluminum in excess. So that is how much aluminum we have left over. Now let's try this problem here. It's a little different. We start with 90 grams of iron chloride and 9.2 liters of hydrogen sulfide. What does a mass of HCl produce? Now, if you're given 2 reactants like this, we're going to need to, that's limiting reagent, Also, if they ask for excess, we're going to have to do a limiting reagent. We're going to also have to do the equation here, so you will be required to figure out the equation. So if we do FeCl reacts with H2S, HCl is produced, so we know that. Now what else is produced? Well, we have to say the iron, what else is left, must go with the sulfur double replacement reaction. Now, what amounts does that go into? Well, sulfur is 2 minus. This iron must be 3 plus since this was a 1 minus. So that was iron 3. So that must be iron 2S3. And then we need to balance that. That looks balanced. All right, now let's begin. Let's start with 90 grams of iron chloride. Step 1, find the moles. In 1 mole of iron chloride, we have 162.2 grams of iron chloride. And then we got to go to mole ratio. From the equation, we have 2 moles of iron chloride, and the thing we want to find out how much HCl is produced, and that is 6 moles of HCl, and then 1 mole of HCl is equal to 36.46 grams of HCl. Goes 60.7 grams of HCl produced from the 90 grams of iron chloride. Now let's try hydrogen sulfide. Now we start with 9.2 liters of hydrogen sulfide. Now it's at STP, so STP tells us that we can use 22.4. So don't be scared that now we have liters. It's all the same. Because from liters, what do we want? We just want to go to moles, and we can easily go from moles to moles from liters. And then once we get moles, we can go to moles of hydrochloric acid, then we can go to grams of hydrochloric acid. You might get particles, you might get grams, you might get liters. The same thing, you just go to the moles of that, then the moles of what you want, then the grams. So this is easy. We don't have to even look up anything because it's in 22.4 liters of H2S. We have 1 mole. And now we just use our ratio from the equation. In 6 moles of HCl, we have 3 moles of H2S. Now 36.46 grams of HCl to 1 mole of HCl. See how much HCl is produced from the 9.2 liters of hydrogen sulfide. That equals 29.9 grams of HCl. Here we have the limiting reagent because this is less. H2S is a limiting reagent. Now let's figure out how much excess iron chloride is. We start with 9.2 liters of H2S. We gotta do all that we've been doing, same thing. Figure out the moles, so 1 mole of H2S to 22.4 liters of H2S. So we figure out the moles. Then we do the mole ratio from the equation. Now there were 3 moles of H2S per 2 mole of iron chloride. So again, we're trying to find out how much iron chloride can be produced from the 9.2 liters of H2S. And then 1 mole, we have to figure out the grams, 1 mole of iron chloride. We have 162.2 grams of iron chloride. So we'll see how many grams were used. 44.4 grams iron chloride used. We were given 90 grams of iron chloride and we used 44.4 grams. We have 45.6 grams of iron chloride left in excess.